When we discussed about the galvanometer, I told you there how to calculate current sensitivity. As I told you, in galvanometer we have concluded that I is directly proportional to the deflection in galvanometer. I is directly proportional to theta. With the help of this equation, we can calibrate a scale of galvanometer and convert into an ammeter. Look at this ammeter. This is the ammeter which you use in the lab practically. Again, there is a one positive terminal, another negative terminal. Red one is always positive, black one is always negative. When you connect these two terminals through an external EMF source, current flows through the coil and this ammeter needle deflects on the scale. To take reading from this ammeter, first thing which you need to calculate is least count. How to calculate least count? Least count is the minimum measurement which can be done by any instrument. So just go to the big part. There are so many big parts. Choose any one big part. This is showing 0.5 and there are the number of divisions. Count the number of divisions. So the reading on one big part divided by number of division. This will help you to find the least count of it. How will this least count helps while you are taking reading from the galvanometer? Suppose this needle comes somewhere in between 0.5 onward and next part and so on, or in between that. You can count that number of part and multiply it with the least count, and then you can calculate total reading taken by galvanometer. We can obtain ammeter from galvanometer, and we know ammeter is a device which is used for measuring current, so the internal resistance of this device should be very low. In order to convert a galvanometer into an ammeter, we need to connect a one small value resistance in parallel to the galvanometer. This is a galvanometer. You can connect a small value shunt resistance here. Current flowing through this circuit is divided into two segments. Ig passes through the galvanometer, Is flows through the shunt resistance. Since these two are connected in parallel, therefore potential difference across both the elements will be same. Is over into S. You can calculate the shunt resistance value to convert into a desired value ammeter. Ig is termed as full scale deflection current. Is is the current flowing through the shunt resistance. So you can calculate by this formula how much resistance you need to keep it in the parallel in order to convert a galvanometer into a required value ammeter. Required value, I mean to say the maximum reading which you can take on this scale. But from Kepler's